So today we're continuing on looking at ordering and comparing fractions. So nothing too greater than what we did last day. I didn't want to dump everything all in one lesson, so this is going to be a short one. But in this lesson, we're going to do a lot more sort of mental math. Okay, and after this lesson, we'll get into how to add and subtract fractions, multiply and divide fractions, and using our BEDMAS rules for fractions. All right. So you can be given questions like this on a number line, and you go, hey, on the quiz, I just asked you for what does one dot represent. Here we got a list of numbers, and I'm asking you which number belongs to which dot, and try to do it without using a calculator. And we can do that through like a process of elimination. All right, we go, okay, we have 4 over 10, 1/2, negative 5 over 4, and negative 4 over 5. Looking at this, can you tell me which one's going to be the most negative number? Which one's going to be the furthest to the left? Just without doing any math. Right? Which number is going to be the furthest to the left?
Negative 5 over 4.
And how do you know that, Logan?
Because it's the greatest number with the negative beside it.
Yeah. So both of these are negatives, right? And Logan said the 5 over 4 is bigger, or more to the left because it has a bigger numerator. So that's going to be like 1 point something. The other one's less than 1. Right? So right off the bat, without doing any calculations, we can say negative 5 over 4 is going to be the furthest to the left. So which dot would negative 5 over 4 be? So out of the ones we have to choose from? C. Yeah. Okay. Okay. Looking at the other end of the spectrum, can you say which number is going to be the biggest? Which one's going to be D? So which one's the most positive and to the right?
1 over 2.
1 over 2. And how do we know it's 1 over 2?
Because that's a half.
That's a half. And how do you know half is bigger than this?
Because that's not 5 over 10.
Yeah. Good. So you go, this is a half. For this to be bigger than half, what's the halfway mark here? It would be 5 over 10. So it's smaller. So this one is the furthest to the right, which is our D. Okay. Right?
Wait, I thought the half was D.
Oh, sorry, D. Yeah, other way around. Yes. D. Thank you. Thank you there.
It's A.
Yeah. Okay, so we have 2 numbers left. All right. What's 4 over 10? A. It's positive. What's negative 4 over 5? B. It's the only negative number left. Okay. So you can do these questions without using a calculator, and that's the whole point of it. Right? And so I'm not going to go through these. You can fill these out. This is sort of the process we went through our mental math to eliminate choices to figure out which one's the biggest, which one's the smallest, and go from there. Right? So take a moment and do this one. It's a little trickier. Right? I'll give you like a minute here. See if you can, without using your calculator, figure out what letter matches up with what number.
It's just hard.
Right? I'll just give you a minute, then we'll talk it through. So let's begin here. I think looking at these, the hardest ones to differentiate is the letters E, A, C. Right? The other ones, we should be able to do it, hopefully without using too much brain power. Right? Looking at F. Right? The furthest to the right here. And on the number line, it's going to be a number slightly bigger than 2. So which fraction or decimal would this be here?
2 over 5.
2 over 5, right? We have a 2 here. And that 1/5. So 2 and a little bit bigger. So this could be F.
And then that made 7 over 14.
That would make the other one E. And you can tell that 7 over 4 is not bigger than 2 because for this to be bigger than 2, this would have to be an 8. 8 divided by 4 is 2. Right? So you know it's slightly less than 2. So we can go then this would be D. Okay.
Middle one, C.
Let's go with the furthest one to the left. Which one's the biggest negative? So we're looking a number slightly to the left of negative 2. Sorry?
Negative 2.1.
Yeah. Negative 2.1. Oh. Negative 2.1. So B is slightly to the left of D. Sorry, negative 2. So that B. B. All right. Then we have the hard ones. E, A, C. So now we've got 3 numbers left to choose from. We have a negative a third, negative 0.3, and negative 0.49. Okay. Of these, let's talk about negative 0.49. Be 0.3 and 1.3 is going to be kind of very similar numbers. So negative 0.49, which one would that be? E, right? It's the biggest number of all these. And that means it's going to be the furthest to the left. All right? So that could be E. Okay. And we have A and C left to choose from. If I turned 1/3 into a decimal, what would that be?
0.3.
0.3 continuous. This is one of those fractions that you should know off the top of your head. Like a third, a quarter, a half. Those are some of the common fractions you use so much. You should sort of just know what it is. Now, comparing 0.3 to 0.33, which one's closer to 0?
0.3.
Right? 0.3. Is everybody okay with that?
Yeah.
So that would mean that this one, out of the choice of A and C, which would
That'd be C.
be C, that would leave that to be A. Right? So you'll get to a point in your classes, I'm not sure if I'll do with you guys or in your math classes. It's a lot of things you can do easily on your calculator, right? But we want to know if you can go through the process mentally. So you'll get to a point where it'll be like, hey, you have non-calculator portions of the test. It's like, okay, close your books up, put your calculators away. This is non-calculator portion. So this is kind of the process you have to kind of go through. Then be like, okay, open up your books, open up your calculators. You can use it for the second half. So make sure you can go through the process, not just rely on your calculator. Okay. All right, next part. Part B, compare matching fractions to number lines. All right, so in this question, we want to identify the rational, there's a typo number. That means a fraction in between the two numbers given. Right? What number is exactly in between these? So if I put these on a number line and I had 3/4 would have been right here and I had 4/5 over here, what number is exactly halfway in between? Right? And what we learned last day is the way we compare numbers is either having things in decimals or having things as a common denominator fractions. So we're working with fractions here. So we're going to convert everything to have a common denominator. Okay. And then we can compare the two fractions and figure out what's in between. So if we have a 4 and a 5 as our denominator. What would our common denominator here be? What's the smallest? Sorry? 20. They can both go into 20. So we need to multiply the first one by 5. So that gives us a 15 over 20. We multiply the second one by 4. That gives us 16 over 20. Okay? So now they have the same denominator, so we can compare the tops. Well, we have 15 and we have 16. What number is halfway between 15 and 16?
15.5.
15.5 over 20. Now, 15.5 though mathematically there's nothing wrong with that number, but it's not a proper fraction, right? You shouldn't have a decimal in your numerator. So we have to do a math trick to get rid of that decimal, right? And you go, hey, if I just multiply the top and the bottom by 2, make them equivalent fractions, I can make this out of bottom out of 40, the top 15.5 times 2, 30. That would be the rational, the fraction.
Yeah, it would be 31.
31, sorry, 31 out of 40. And that would be the number right in between there. Does that make sense? Right? And this trick, if you get familiar with it, it can help you a lot. Like I used to teach this trick to my science students. And when you're balancing atoms in science, you guys remember that, right? And you're going to do a lot more of it in Math 10. And you have to balance your carbons and your hydrogens and your oxygens. And you're balancing everything out. You ended up with, hey, 2, 3, you're left with the oxygen at the end. And you couldn't make it work. The only thing that would work was like, say, a decimal, right? What you can do is, mathematically, this is correct. Chemically, it makes no sense because you can't have a half an atom, right? But what you could do is once you came to this point, just multiplied everything by 2. You could have had C4H6O3. That would be your balanced molecule. So remember, this is going to happen again next year. Depending on your teacher, they may or may not show it to you, right? I always say balance it mathematically. Then, because the math makes sense, then you just got to make it make sense for the science, the chemistry. You got to have a whole number. So you just multiply by 2. Or if the decimal end up being 1.3, multiply by 3, right? It makes it a lot easier than just guessing and checking and going back and forth. But for math 9, that's all you need to be able to do. That's fine? Okay. Okay, going over here is a slightly different question. Okay, find all the integers in between these numbers. So in order to do this, we need to know what the word integers means. What is an integer? You guys know what an integer is? Right? Nobody? Okay, integers are your counting numbers. You have whole numbers, which are your counting numbers, like 0, 1, 2, 3, 4, 5. Integers are your positive and negative counting numbers. So all your whole numbers, positive and negative. Negative 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5. That's what your integers are. Okay? So in order to do this, we just need to know what our boundaries are. We go negative 7 over 2. What is that number as a decimal? So grab your calculator and negative 3.5. Thank you. And what's 11 over 3?
3.6.
Thank you. 3.6. So if we put this on a number line, the negative 3.5 would be somewhere over here. And the positive 3.6 would be in here. What are all the integers in between?
Negative.
So you start from the left and you work your way over. So what would be the integer immediately to the right of the negative 3.5?
Negative 1. No, negative 2.
No, there was something before that. Negative 3, right? Then what comes after that?
Negative 2.
Negative 2, negative 1. What's after that?
0.
0. Don't forget about 0. 1, 2, 3. So those are the integers, in between there. All right? That's it. So it's not I don't think the difficulty level of these questions are very hard, but it's just knowing the terminology. Okay. Last question for today. So on the previous page, we worked with fractions. This page, we're working with decimals. So we can do both things in both ways. And we want to place these numbers on the number line. Right? So we convert the fractions to decimals. The first one, we don't have to do that. So we go 5 over 8. What is that as a 0.625? 0.625. And what's negative 9 over 10? Negative 0.9, so negative 0.9. And we're left with 9 over 10, which would be just positive 0.9. Okay? Now, to make it not so messy, let's just label these things. Right? So we can put it on the number line. So let's call the first one A, B, C, D, and E. So we can just plot those points on there and call them. Right? So before we can plot these points, we need to know how much is each line worth. So how much is each line here worth? If that's a 1 over here, what is this line worth?
2 each. 0.2.
0.2.
1 and 0.2.
Well, if this was 2, that'd be 4, that'd be 6, that'd be 8, that'd be 10 right there. Right? It's 1. So this is 0.2. This is 0.4. This is 0.6. Right? In the other direction, it'll be negatives. Okay? So, I'm looking for a little bit of accuracy here. A, negative 2.2. Where would that go?
1 over
The hash right after the 2.
Right after the negative 2. The hash right over. So that would be A. Okay. Where would B go? 0.625.
Go like 3 after the 0.
3 after the 0. People agree with this?
A little bit past it.
A little bit past it.
Yeah, because it's 2, 5. So
0.25, right? So if you put it right on the line, I'd mark it wrong. So a little bit past.
because that would be a quarter of that.
Yeah. There we go. And that's what I'm going to be looking for. I'm not looking for it to be perfect, but I'm looking for it to be reasonable. Right? C. Where would C go? Yes, Logan.
Right in between the 1 and the 2 on the right side. Negative 1 and negative 2 on the right side.
Right in between negative 1, so right here?
No, like right in between
the negative 1.
negative 1
And
and then
the
the
other
1
way.
immediate to the right.
Oh, okay, I see. Right? So that would be C, and I agree. Right? So this here is negative 0.8. So you want to draw the line, draw the dot halfway between. Okay. Where would D go? Negative 0.3.
2 over from C.
2 over.
3 over from C, and in the middle, the third and fourth one. Or like the first and second. Or actually the
The
second and
first
third
hash mark and then
one. Or let me just call it.
All right.
halfway in front of
Harinder, what's your directions here? Start me at 0.
Start at the 0.
Yeah.
Go this way.
1.
Go this way 1 full time, and then go in between the half.
Okay.
E.
Is that where you're describing it right there?
Yeah.
And so that's 0.2, that's 0.4. That is a reasonable one for D. All right. E. Yes, Logan.
Right behind the positive 1 in between.
Yeah. So a mirror of the other one over there. So that would be E. Right? So I'm expecting you to be able to do something like this. All right. So that's just putting it on a number line. Now, if I ask you to write out in ascending order, use like we did last time. You look at the original one. So you go ascending means smallest to biggest. So we start off with A. That'd be negative 2.2. Then we go to C. That would be our negative 9 over 10. Then we go to D, which is negative 0.3 repeating. Then we go to B, which we said was 5 over 8. And E, we said was 9 over 10. And that's it. Pretty straightforward?
Nope.
Yeah. Okay.